Hello everyone and welcome. In this video, we are going to learn about CCTP. As you can see here, I have my old project. So this is the developer controlled wallets project. I just created a new branch called CCTP and I added the CCTP functions. Basically, we are going to use the same project but with a couple of additions. Make our transaction, then let's see how it works. Before starting the code, let's look at this infra. So we are going to need some RPC URL, and for that reason you can use Alchemy, Infra and many other services. Here I'm using Infra, so if you go to Infra and log in or sign up, then you are going to see my first key. And then I will click on it, and here you will find your API key. Once you get your API key, you will go to this CCTP functions.javascript and you are going to paste your API key here. And if you are using another service, just get the URL for your RPC and put it here, since we are going to make use of Web3 library. Now let me put my API key here. Let's go back to our code. So let's start with index.javascript. Now let's explore index.js, and this is where the magic happens. So if you scroll down, you will see a separate part for CCTP, and these are all previous examples. And here you will find CCTP. So first thing to do is to get an approval for our transaction, because what we are going to do is we are going to communicate with smart contracts. So we are going to tell smart contract that I want to burn USDC here. We will also say smart contract that I want you to mint USDC. So this is how it's gonna work. We are going to burn it on one side and we are going to mint it on the other side, and this will be our sending process. So first of all, let's go to approve USDC, and before running this function, I want you to show you the .env file. I have this .env here, but you will not have this file because it's not on GitHub, but you will need to create this. So you can use the same env file from your previous project. Now here, as you can see, I have my sender wallet ID, sender address, receiver address, and receiver wallet ID. These will be necessary for our operations, and also we have contract address, token messenger address, and message transmitter address. And also these will be necessary during our process. These are the addresses of smart contracts that we are going to interact with. And I call these static because we will also have this dynamic part. What we are going to do is we are going to get these variables and we are going to save them and we are going to use them in our code. In reality, in real life, what you need to do is you need to return these variables, and the functions should do these automatically. So from one function, I'm going to retrieve one variable and I'm going to make use of that variable. So this is how it's gonna work in a real life situation. But since I want to show you how to do it step by step and I want you to see what we are using, I created this .env file like the previous ones. But again, for your real life applications, you don't want to do this by hand. Anyways, you cannot do this by hand. So you cannot copy and paste. You need to retrieve from one function and use it in another function. That being said, I will tell you one last thing. If you go to helper functions and if you go to the create wallet, this is the previous developer controlled wallets chapter. And as you can see, we have in the blockchain section Matic Mumbai here. If I also add this Ethereum Sepolia, then it's going to create both wallets. For this, you need to have a wallet in Matic Mumbai and Ethereum Sepolia. If you have already your Matic wallet, then you may just want to create this one. But in any case, you will need both wallets because we are going to send from our Ethereum wallet to the Matic wallet. But again, after you learn this, you can make use of many different blockchains. All being said, it's time to try our approve USDC. First, I'm going to say npm run start. Don't forget to say npm install in the beginning once you get this repo. After that, you can say npm run start. I uncommented this line, so that's the only executable in this file. Now let's say start. And here, as you can see, it returned me an ID and the state is initiated. Now I'm going to comment out this one, and for our second step, we are going to burn USDC. So what we just did is we just got ourselves approved so that we can burn USDC. Now I'm going to say burn USDC. I will say npm run start, and as you can see, we got our data here. This encoded address is just for you to see, and I'm going to talk about this in the function, but that's what we are going to need. And I'm going to copy this ID. Since we got this after the burn, I'm going to put this under the burn transaction ID. In the next step, we are going to get attestations. So this will return us a message bytes and also, let's say, attestation code, and we are going to use them to mint our USDC. So as the third step, I'm going to uncomment this and let's run it and see what's going to happen. It may take a couple of seconds or minutes because it's waiting if our transaction is confirmed. If we go to Circle website and if I go to dev controlled wallets and transactions, as you can see here, my transaction, the latest one, is confirmed. It is waiting for it to be complete. So whenever this is complete, then we will be able to move on. Now we got our message bytes and we have attestation response, and here, as you can see, we have this long ID. Now I'm going to copy these message bytes and I'm going to paste it here. But again, this is not the ideal version. I'm just doing this so that you can be aware that we are using message bytes and attestation, but in your process, you, instead of consoling this or console logging this, what you want is to retrieve from the function again and use in another function. And for the attestation, let's get this ID. So basically what we are doing is we are just running functions, getting IDs and passing them. Now for the last step, I'm going to say mint USDC. Now let's run this. And here we got an ID. It says initiated. Let's check our transaction. Here, as you can see, we have one confirmed USDC in our Polygon Mumbai. If we check it, here it's confirmed. Amount is 1 USDC and we have all other information here. And if we check the receiving wallet address, it's end with 315. And let me check the wallet. I got a lot of wallets. And before going into the wallet, I'm going to say that we had 11 USDC in the beginning in this wallet. So at the end, it should be 12 if it's working. So let me go to this wallet. And as you can see, we have 12. And here you have, folks, that's how we can use CCTP. It's a really, really easy process after you set it up. And now let's look at the functions that we have used for this process. So first of all, we have our Web3 instance here. And again, we are going to use this to encode our destination address. We have a separate function here, which is get ciphertext, because every operation that we are going to do, we will require a new ciphertext from our entity secret. I'm going to use this generate ciphertext, which is from the helper function, which is the function that you have already written, or you copy it or you downloaded it, whatever you did. It's the same function from the previous chapter on developer controlled wallets. Here is our function. Now, after this, we have our first function, approve USDC. And I'm going to get my ciphertext here because we are going to use it. Here is my URL for my post request. I passed my API key here. It's just like the processes we did. Here we got our API parameters, so you don't have to worry about them. This indicates that we are sending 1 USDC. And we are going to need an idempotency key. For that, I'm using UUID-v4, exactly the same thing that we have done before. So there's nothing new here. For the contract address, we are going to pass the contract address, and this will be the contract address that you are going to communicate to in the source destination. Then I'm going to pass the sender's wallet ID and finally the ciphertext, and at the end I'm consoling this JSON. But again, what you need to do is, in a real life situation, you should tell this to return. Instead of console logging this, you should return this whenever it's needed. For approve USDC, you don't need any variable that you got from here, so you are good to go in this case. Then we have burn USDC. As you can see, we still have our ciphertext and we have our encoded destination address, and that's why we are making use of Web3. We are going to encode our destination address, and for that we are going to call web3.eth.abi.encode parameter. We are going to pass address here and also the receiver address. So whichever wallet is going to receive your token, you are going to pass it in here. Console logging the address for you to see, but you can get rid of it if you like. And here again, we have a couple of parameters here. First of all, this is the function signature, and this is the function signature in Solidity smart contract that we are communicating to. The other parameter, or the parameter that you are going to pass here, is the encoded destination address. So this should be encoded. And again, you can encode with this function here. Next, it's going to require idempotency key, and here you have it. I generally use this So even though I don't have to put these, the reason I put this so that I can just, it's just easier for me to see. So whenever I'm just looking at the code, whenever I see this instinctively, I know that I use this in something. So that's why I do it, but you can just get rid of these if you like, let's say like that. And you can have much more clearer code, let's say. But again, this is just my personal preference. Here, I'm going to pass the contract address. This time, we are going to pass the token messenger address. So this is the token messenger contract on the source blockchain. Next, we are going to pass the wallet ID. Again, this is the wallet ID of the sender. And finally, the ciphertext. This is a different ciphertext we are regenerating in every function, as you can see. So in this CCTP sender wallet ID, why the sender? Because we are burning some tokens. I'm going to burn the USDC I have, and we are going to mint in the destination wallet. For that reason, we need the sender. And finally, we are going to fetch this. This will be a post method, and in the body we will just have a data, and finally we are just going to console log this data, and this will burn the tokens for us. Again, you will have the code for, you can examine it, you can try a couple of things, and this is just not the only way to do it, but one of the easiest way, let's say. Then we have fetch deposit transaction, and this will be necessary to get attestation. What we are doing here is that we are getting this burn transaction ID, and at the end, what we are trying to do is we are trying to get this transaction object through this transaction ID. That's why we are using burn transaction ID, and with this call we are getting this transaction so that we can use it in this get attestation. So here, as you can see, we got transaction object using this function, and as you can see, I'm returning this here. I left this as an example, so if I want to return and use this, how you can do this? You are going to return this fetch, so you are going to return this promise first, and from this promise you are going to return json.data.transaction. So once I return this with this function, I can use it in here, as you can see. Also, how you can use the variables in the env file instead of just copying them and, you know, like pasting and copying everywhere. So that's the ideal way how you want to do this in a real life situation. Next, after having our transaction object, we are going to have our transaction received using this get transaction receive function from Web3, and we have just couple more, let's say, functionalities here, but what we are doing here is more important than how we are doing, because that will be standard. You can just copy and paste this. What we are doing is we are decoding and creating message bytes and message hash with a Web3 library. That's a long name. So at the end, if you remember, we were having a message bytes and attestation, and that's how it's worked. This is where the magic happens. And finally, what we are going to do is we are going to fetch this. So we just created the setup, and now it's time to see the truth. As you can see, if the status is pending or the status is not equal to complete, this is going to wait. That's why we waited until our transaction status was complete. So we were waiting, it was confirmed. Once it was complete, then it works. So if you remember our waiting here. And at the end of this function, as you can see, we are returning message bytes and attestation, and I'm also console logging here. So if you want to just grab this and use it somewhere else, you can. That's why I just constructed the code that way. So it's not the final product, but you can just use this or edit this using this ideology and methodology. But for the demonstration purposes, I got my .env. The final step is the mint USDC. I got my ciphertext and I got the message bytes. It wasn't necessary for me to put them here. Again, as you can see, I'm not making use of it, but it was for you to see. Now we are going to make our post request. I'm going to pass my API key. The important part here is that for our API parameters, we will be passing our message bytes and attestation. And then we are going to provide the idempotency key and the contract address, and this will be the message transmitter contract address on the destination chain, not the source chain. And finally, we are going to pass the receiver wallet ID. So it's not the one who is sending, but it's the one who is receiving, and the ciphertext, because what's going to happen here is that we are going to mint one USDC in the destination chain. In our situation, it's going to be Matic Mumbai. And finally, we are going to fetch this request, and that's the final thing that we see on our screen. Here you have it, folks. So that's how you can make cross-chain transfers. Thank you very much for sticking with me the whole process of this course. I wish you the best with your final project.